Hi everyone, welcome to the channel. So in today's video, we are going to see the random walk, especially with the Apple stock. So what if I told you that Apple stock might just be a drunk person stumbling through the Wall Street? So in today's video, we are diving into the concept of random walk, a core idea in quantitative finance, and we will compare with the actual historical price of Apple stock. So let's test the efficient market hypothesis. So first thing first, what is random walk? So in quantitative finance, the random walk theory suggests that stock price move randomly and cannot be predicted. So it underpins the efficient market hypothesis, which says all available information is already priced in. So if market are efficient, your best guess for tomorrow price is today's price plus some noise. So let's code a random walk in Python. For that, let me first import the NumPy. And let's import pandas, and for visualization let's import the Matplotlib. Now let's some parameters for let's put random seed so our results can be reproduced. And let's put the famous 42. So we want 1 year of trading days, that is something like 252. Mu drift will be 0.005 maybe, and sigma is 0.01, that is volatility. Now let's do simulate the random walk. For that, simulate the random walk. So we are going to, let's do NP random. I will use normal. Scale forwardity is sigma and size for 1 year, right? And let's store into returns. All right. Let's put a starting price of maybe 150 and random walk is will be price plus our comport 1 plus return. Additional. Now let's plot it. PLT dot let's plot random walk and let's add the label random walk. Oh, let's close this. So we got this random walk. Let's add few things. Our title plt dot x labels are what? Trading days. while labels are the price. Right? Just for beautification of this chart, grid equals to true and PLT shows, so we don't get this text. Oops, it's legends. All right. Okay, maybe let's increase out this. All right. This looks like a good example. Now let's, so we simulated 252 trading days with daily drift and volatility. So the result is the price bar just from the noise. So now let's compare with the Apple stock. So for that, let's import the yfinance. Let's data, let's download our data. This is the ticker name, Apple. So if download ticker name. So we'll give start maybe let's do 2024. Let's give the edits. So we are storing in the Apple. And now let's add the returns column. And to calculate returns, we'll just use close and the city change. And let's do the cumulative returns. So formula is 1 plus your return import. Okay. So get no data for this. Oops, and it should be the yeah. So we downloaded our data. Now let's plot the Apple versus random walk. So let's use the same. So here we are plotting AAPL cumulative If we shoot the values on this, label this as the Apple actual price. And let's plot the simulated data for this. This is fine, great. Let's run this. And look at that, it's almost. So here's the Apple stock from 2014. So we normalize the cumulative returns to match the starting point. And now we can visually compare Apple's real behavior against the random walk. So at first glance, you can see, okay, all right. So I just fixed one small issue we had. I was using the cumulative values. Now I'm back to the price. So this is the actual price, and this is the random walk. As you can see, in the first glance, the real stock and the random walk may look similar, but as the closer, Apple shows the trend jump and cluster of the volatility. So real markets are not pure random walk. There's a structure, noise, and sometimes the alpha. So efficient market, not perfectly, but randomness plays a massive role there. I can also do a Monte Carlo simulation. For that, let's do multiple random walks. So multiple random walks. For that, let's run a for loop in range. We do 10. I will just use this. So returns is calculated by this music note side step n, and let's put walk as price multiply plus returns, and let's plot this. So PLT plot, we are plotting the walk, and let's put alpha. Look at that. So we can run. So this is just an example of the Monte Carlo simulation for 10. Uh, so is this the Apple stroke a random walk? It's kind of yes, but the market hides pattern beneath the noise. So that's the challenge and definitely an opportunity. So if you like this breakdown, just hit the like button. Thank you for your time. I will see you the next one.